Hi everyone, in this video we are going to learn about coefficient of determination, which is called R square. First we'll learn about what is the coefficient of determination and what is its importance and what this R square actually tells about the linear model. Then we will understand the calculation of this R square or coefficient of determination. Okay, coming to this R square, to understand about R square we should know about the first of all we should know about the regression. So in the regression, when we try to predict the variable y using the values of x, so we create a line graph with the help of this line graph or linear model. We can predict the variation in the y with the change of the change in the x variable. Okay, so when we create this straight line, so we see that there is a difference in the actual values of y and the values of the linear or the straight line. Okay, so when we see the data of this particular this regression model, okay, let's see the values of x variable like 1 2 3 4 5 6, and the observed values of y, are like 2 3 4 5 6 7. So in this graph we can see that the blue line is the predicted y values, and the orange line that indicates the values of the actual values of the y variable, so we can call them also observed y values. Okay, and when we use this system to find out the change in the y variable when the change occurs in the x variable, so we create this linear model or the regression line. But when we create such a line and to predict the y values, so we actually use r square also. This concept of r square tells about how much variation in the y is coming completely from the x. Okay, the change in the y is not completely comes from the change in the x. That means there may be other variables which also influences the change in the y, but to know how much variation that we can capture uh, in a y variable using the x values, okay, that is explained by this coefficient of determination or the r square. Okay, coming to calculation, first we have the values of x and also the values of the observed values and the predicted values. Okay, so first we have to calculate the mean value for the y variables. When we calculate the mean values, we know the sum of the all values divided by the number of values. So the sum of y so sum of values of y variable is equal to 27, and the number of total values is 6, so therefore the mean value of the y variable is 4.5. So we can see this horizontal blue line which indicates the which shows the mean value of the this y variable. Okay, so the third step is calculating the SST, that is called the total sum of squares. How to calculate the total sum of squares? So total sum of squares is calculated by subtracting the mean value from each y variable. So we have to subtract the each these values, y variable values, from its mean value, so that we get the total sum of squares. So the total sum of squares in this case is 17.50. For example, the first one, so the mean value is 4.5, so the observed value is is okay 2, so therefore y minus y bar, that means y minus y bar becomes minus 2.5. So when we square it becomes 6.25. so why we do squares here to give the more finality to the less values, and give more values or more score for the higher values. So that's why we use this cursor. Also the negatives becomes the positive. So when we subtract each data point from its mean value with respect to the y variable, so we get the initially their individual the mean difference values, then we square it. so that becomes the total sum of squares, that becomes 17.50 in this particular example. Then the next one is the calculating SSE. How to calculate this SSE, sum of squared errors. This is very important, sum of squared errors. So the formula of sum of squared errors is sum of yi minus y cap square. So we calculate this particular sum of squared errors 0.12 by subtracting its observed predicted values from their observed values. So the predicted value is y cap, and the observed value is y. So we subtract its predicted value from its so we subtract their observed values from its predicted values, and we sum all these values, the differences in the predicted and observed values, that becomes the sum of squared errors. So the sum of squared errors is here 0.12, and the formula for calculating this coefficient of determination, that is r square, is equal to 1 minus sum of squared errors divided by sum of square total sum of squares, that is or sum of squares of total. So in this case 1 minus 0.12 divided by 17.50, that becomes 1 minus 0.006857. So when we subtract this value from the 1, so we get 0.9931. So when the r square value is 1, that means all the variation in the y variable is completely because of the x variable. So when we get a value like 0.9931, that means 99.99.31 percent of variation in the y variable is because of the x variable. That means most of the variation we are able to capture using this particular straight line. Therefore we can say this, that okay, this straight line is a good fit for this data, particular data. So this is how we calculate the r square for the regression models. So this r square for regression models tells us that how much variation in the y we can the y variable we can we can understand using the variable of x. So this is about the r square. Thank you.